Have you ever stopped to think about the invisible rules that, well, keep our world from falling apart? I mean, the building you're in right now, the car you drive, the power that keeps the lights on, all of it works because of this hidden system of safety. And today, we're going to pull back the curtain on one of the most critical and honestly most overlooked parts of that entire system. All right, so let's dive right in with a question for you. What on earth could a simple can of soda possibly have in common with a nuclear power plant, one of the most complex things humanity has ever built? The answer is actually pretty simple, and it gets right to the heart of what we're talking about today.
Okay, so part one of the answer is pressure. A soda can, it holds about 3 times the pressure of the atmosphere around you. A nuclear reactor, on the other hand, can operate at over 150 times atmospheric pressure. But here's the thing, both are specifically designed to contain that force safely.
And that gets us to the real answer. They both operate under a hidden but incredibly detailed system of rules and standards, a system with one single goal, making sure nothing goes wrong.
So, let's start by getting a handle on this force we're trying to contain, pressure itself.
See, on one hand, uncontrolled pressure is without a doubt one of the most destructive forces out there. It can lead to total, catastrophic failure. But on the other hand, when you control it, when you engineer it, that exact same force becomes incredibly useful. It gives us everything from steam power to, you guessed it, fizzy drinks. The only thing standing between danger and utility is just really, really careful engineering.
So how do you manage that careful engineering on a huge scale? Well, it all starts with what you could call a master safety rulebook.
And that rulebook is the ASME Boiler and Pressure Vessel Code, or BPVC. Now, ASME stands for the American Society of Mechanical Engineers, and for more than a century, this single code has set the high-level safety rules for pretty much anything that holds pressure. The best way to think about it is like the lead architect on a giant construction project. It has the big picture vision for keeping everything safe. And this lays out perfectly how it all works. The goal, right at the top, is simple: contain pressure safely. So the BPVC, our architect, sets the main rules for how to do that. But you know, an architect doesn't also personally design the plumbing and the wiring and the exact type of bolts for the foundation. For all that stuff, the architect has to rely on specialists. And the BPVC works the exact same way.
And this right here, this is the core idea of this whole explainer. That master rulebook, our architect, isn't just one book with all the answers. It's actually a code that's built on top of many, many other codes.
And hey, you don't have to take my word for it. The code says so itself, right here. In Section 8, it straight up tells you that it references a whole bunch of other standards, and it even says where to find them, and a little thing called Table U-3.
This one table, U-3, is the key that unlocks this whole system. Seriously, think of it like the Rosetta Stone. It's the tool that translates the architect's big picture goals into the super specific, detailed instructions that come from dozens of other expert sources.
So come on, let's take a look inside this Rosetta Stone. You are going to be amazed at the level of detail it connects to.
First off, you've got standards for all the big obvious pieces. You know, things like the actual steel pipes that carry the steam, or the huge flanges that bolt everything together. These documents specify everything you can imagine for the main structural parts. But it doesn't stop there. Not even close. Look at this! The system is so incredibly detailed that it points to separate standards just for the threads on a screw, or the specific kind of nut you need to use, or even the design of a single metal gasket. Because the safety of the whole thing depends on every single part, no matter how tiny. And then, it goes even deeper. The system doesn't just tell you about the parts, it specifies the fundamental properties of the materials used to make those parts. There are entire standards just for how to test a metal's hardness, or its ability to resist cracking, or how it's going to act in freezing temperatures. This is the scientific bedrock that the entire safety system is built on.
So how many of these specialist documents do you think the master rulebook points to in just this one section we've been looking at? What's the number? It's 48. That's right, 48 different, super specific rulebooks for everything from bolts to welding to material science, all woven together, all referenced by one part of the main code, all to create a single unified system of safety.
And when you zoom out, you start to realize that this system of 48 interlocking standards isn't just a pile of documents. It's actually a massive global effort.
I mean, this web of codes represents decades and decades of learning, often, unfortunately, from past failures.
It's built on the collaboration between companies that are normally competitors, and it contains the collective wisdom of countless engineers from all over the world. It is, simply put, a global commitment to keep every single one of us safe from the incredible power we've learned to control.
So in the end, this isn't really about one rulebook. It's a living system. It's a shared language that lets engineers all over the planet build incredibly complex things safely. It's like an invisible shield, one that's been forged from knowledge and collaboration, and it's protecting us every single day.
Which kind of leaves us with one last thought. We just got a peek behind the curtain at one of these amazing systems. So what other invisible systems, what other codes and standards are working right now in the background to keep you safe?